Means of conceptualizing and visually depicting the Internet have evolved over the 30 years of its existence. From the Advanced Research Projects Agency's 56 kilobit ARPANET to the National Science Foundation's NSFNet to the T1 backbone linking supercomputer centers to the wider and faster T3 backbone and network access points, NAP, architectures, to the commercial internet connecting millions of computers together through complex networks in over 100 countries. Today's internet is comprised of a mesh of internet service providers and backbone networks, network access points and private peering sites where ISPs exchange traffic, and end-user facilities. The Cooperative Association for Internet Data Analysis, CAIDA, based at the San Diego Supercomputer Center, is developing tools for visualizing aspects of the Internet that are beyond the scope of individual networks. Such visualizations can depict topological representations of networks and hierarchies, provide insight into the structure and characteristics of global caching hierarchies, display the relationships among autonomous networks, or give a geographic representation of IP connectivity of Internet backbones. CAIDA is developing a prototype tool to test the usefulness of geographic depictions of backbone networks. The Internet is a mesh of different backbone networks. The major provider backbones come together to form a complex, sophisticated infrastructure that enables communications across distant parts of the globe. CAIDA is developing a tool that will depict the geographic layout of these networks. CAIDA's tool, named Mapnet, builds its geographic layout, which is a topology much like a roadmap from the database containing information about links and nodes, which make up the component parts of the backbone networks. The latitude and longitude coordinates for individual nodes in the database are laboriously derived through a manual process of extracting location information from various sources. The rapid evolution of Internet backbone networks makes static databases like this one nearly impossible to maintain. The topology information collected in the database is gathered from trade publications such as Boardwatch magazine and from ISP websites. While a few network administrators actually enter latitude and longitude data in their domain name system records, most do not. Registering this data is recommended by the Internet Engineering Task Force's RFC 1876. Also, the accuracy of the data from such public sources is difficult to authenticate and often unreliable. Despite these difficulties, CAIDA views the use of the Mapnet tool as a crucial step in visualizing the complex Internet infrastructure and in illustrating the physical interdependencies under which Internet service providers operate. Mapnet is a Java applet with an interactive front end. It is designed to display the infrastructure of multiple backbone providers simultaneously. In this way, customers and providers alike will gain a more thorough understanding of the capabilities of specific backbones. These insights will permit network customers to better select providers and enable providers to better engineer the intricate peering relationships of their networks. The Mapnet tool breaks down the architecture of each backbone into groups of network nodes and links connecting the nodes. This information is then displayed on a geographic map. Users can select specific subsets of the Mapnet data and thereby control the complexity of the presentation. Selected networks are identified in the lower left window. A dynamic legend assigns a different color to each network. Rest the mouse on a specific link, and the cities where that ISP's link terminates will be listed in the lower right window. Rest the mouse on a node, and the lower right window will list which of the selected ISPs have links coming into that city, the bandwidth of those links, and any publicly available peering information about those city ISP pairs. Zoom features permit users to view a specific region of the country with greater clarity. The background map can be removed to focus on the actual network connections, and the sizes of the lines between those connections can be adjusted. You can also color by bandwidth. When you color by bandwidth, a pop-up legend in the main window assigns different colors to varying bandwidth levels. Mapnet is a proof-of-concept tool which demonstrates that many providers are interested in supporting cooperative endeavors aimed at navigating and visualizing the continually changing, complex Internet infrastructure. The accuracy of tools like Mapnet, however, ultimately depends on the providers to keep the information accurate and timely. While tools depicting the physical connections of networks are helpful in visually simplifying the complex Internet infrastructure, they do not provide the level of sophistication required for technical analysis by backbone engineers. CAIDA is currently investigating several alternative ways of dramatically discovering and depicting the intricacies of the Internet and its traffic flows. Collaborations with Internet traffic exchange points such as May West, the Ames Internet Exchange, and the PAX, with commercial and federal networks, vendors, and universities, permit windows into the Internet infrastructure from which CAIDA, the National Laboratory for Applied Network Research, and others can gather and analyze traffic workload information, conduct performance measurements, and analyze routing data. Measurement tools such as Coral, CFlow-D, and Skitter that are under development by CAIDA and collaborators, and visualization tools such as Manta Ray, Plankton, Otter, and Mapnet provide insights to specific aspects of the Internet, its infrastructure, performance, hierarchies, and relationships. Collecting, correlating, and visualizing the various forms of Internet traffic and routing data are important steps in the continued development of a robust, scalable Internet infrastructure.